If you're building neural network models, it's crucial to understand the different approaches to the gradient descent optimization technique that you can use to improve your model's performance. This is batch gradient descent, stochastic gradient descent, and mini-batch gradient descent. This visualization shows how batch, stochastic, and mini-batch gradient descent behave as they minimize a simple convex loss function with respect to two parameters. This is a general formula that shows a single iterative step that a model takes to adjust its parameter set, theta sub j, in the right direction to minimize a cost function, where alpha is the learning rate. I'll show you the variance of this formula for each gradient descent type for the mean squared error loss function. So batch gradient descent looks at the entire data set of size m before it updates any parameters. So this guarantees that it takes a steady, smooth walk towards a local minimum. However, for large data sets, it can be computationally expensive to compute, and you have to have the whole data set in memory for each step. Also, for non-convex loss functions, batch gradient descent can get stuck at a local minimum rather than reaching the global minimum of the loss function. Stochastic gradient descent only looks at a single instance before updating parameters, and these quick updates can make it really suitable for working with very large data sets. Also, for non-convex loss functions, stochastic gradient descent is useful for jumping out of local minima to reach the global minimum. However, this method is highly erratic and can oscillate around the minimum rather than smoothly converging towards it. Convergence can also be highly sensitive to the learning rate. Mini-batch gradient descent balances computational efficiency and convergence stability by looking at a subset of your training data of size b before updating parameters. This makes it faster than batch gradient descent, but more stable than stochastic gradient descent. However, tuning may be required to find the right batch size for your dataset. Knowing these differences is essential for understanding training speed, memory usage, and convergence stability of your model. Be sure to follow if you want to learn more.